Does the gang of gangs contain itself? Well, I'm not an advanced gangamatician. I'm not educated in Gangnam style. Okay. Today we are going to bring back a feature of the stream that is popular whenever we do it. And we never do it. So there's that. Let's run this again to get a second opinion. You know what? Let's update Sokoban, actually. Why is this not appearing? So this special feature is not appearing. I don't know why. Why is the special feature? I'm telling OBS that I want the special feature to appear. It simply doesn't. Dude, everything is so broken. Am I going to have to make all this over again? Do game engines ship with compilers? No. Well, it depends. So like Unity has their burst compiler thing or whatever, but normally no. Scripts are usually interpreted, although not always. They're almost never compiled down to native code. Why is none of this appearing, guys? I am getting fucking angry. Okay, we're just going to do it over again. I don't know why this is like masked out. Let's delete all these other things. Okay, well that appeared for sure. That really is there. Will make me a little bigger too. Yeah. Okay. Okay, if I copy it, it shows up. Never mind. Okay, hold on. Wait. Oh shit, I'm stupid. Okay. Guys, because I haven't used this computer in a long time and things got misordered, all of this was working fine. I just had my display capture like way higher up in the stack than it's supposed to be. There we go. There we go. No wonder things were not appearing. Of course they were not appearing. Okay, hold on. We got to put the title back in there. And then we could enlarge this thing. Yeah. Okay, those numbers are not the numbers. They're not the right numbers. All right, we're going to run this again. Five 552-380. We're going to double check it. Five 552-381. So we'll call it 552-380. And we could probably delete the parens. Dude, OBS is so bad. It's like, I just want to move this horizontally, and it's like impossible. All right. Okay, I can do it by growing the rectangle horizontally and then shrinking it horizontally. That's quality. Okay. Can hold control to move. Yeah, but I just want to move horizontally. I don't want to move without snapping. A game engine that uses scripting languages that ultimately output an executable. Usually the scripts are just data files that are loaded by that executable. Okay, so predictably I've started streaming and it makes me tired and wanting to not stream. Also, there's that. Okay, so this is like a list of things that we could do to make our bytecode output smaller. And any of these that we do today is a win. And I think we could start with this one. This was made a while ago, but hopefully we can just do this. God damn it. Why isn't this a complete program? Fuck. All right. That's annoying, but maybe it is somewhere. And if I spent a long time reading the documentation, just going to hope we can import input and basic and it'll compile. All right. Let's just see what happens. I might not want to stream tonight. I'm ready to fucking punch a window. Code base in question. Oh, it's from Focus Editor. Fuck. I mean, this is probably from like Simp or something. Oh, this is like input. Where the hell is get mouse pointer position? That sounds like my name. See how fast I get in a bad mood when I stream? It's window creation. So you would think I would think of that. Window. Fucking goddamn it. This is like exactly what I hate. Window type. All right. I'm just going to comment this shit out. I'm going to have some chocolate. I mean, I could download the whole editor, but I assume it has changed at this point. The problem is I was going to sit down and have fun working on these things. Okay, it's actually problem is reported in get mouse pointer position, the first one. So we could just look at that. And then we could do more of these other things if we want. Okay, we finally have a fucking working program. Okay. Right. So you see, for example, we're doing a procedure call. We're putting those return values into V1, V2, V3. Now, I think that the reason we are doing that is because there's like a there's just a base, like a value base. It might not need to work that way anymore, but it used to be like, oh, the return value base is v1 and there's 3 of them. However, and I don't remember if I changed that, but I may have, because the fact that I'm printing these things out, let's go look in bytecode printing. Okay. Yeah, it literally could be any register. So I think that the reason this is working this way is because you used to not really have control over where values went. And now you do. Let's make sure that that's right. It could be that you still don't have control, but we just like lay them out at the call site, you know? Okay. Emit procedure call. Okay. Emit hardened procedure call. Yeah, so see, there's result value number base. But we'll go look at that. Okay. And let me just think about this a little bit more. Like the reason I did that I think it was mainly because I thought at the time that I had to encode everything about the procedure call in that instruction, right? In the bytecode instruction. Let's look at the runner, because that's, oops. When we run a procedure call, oh, I'm not even, I'll call procedure. Okay, people are deleting white space that I like. Handle return values. Handle return values. Yeah, we actually do the move here. So and I'm sure the code generation is similar for machine code. So really, the bottleneck about this thing is just at the building site. what was it called? Register base. Okay, so yeah. So we go here. Now here's another thing. There's sort of two separate issues, both of which I wanted to attack. One of them is that you don't control the value numbers of the return values. The other one is this, is that if there's a big value, we always copy it. And one of the reasons behind the calling convention being the way that it is that I always said, hey, we can do this optimization where you skip copying things, right? And so for that to happen, well, we need to know at this site where that thing it lives in memory so that we could, you know, put it in there. And so the laundry's being a little loud. So the question is, what is the series of steps we take to fix both of these? So I'm going to need to pass into here information about each return value. We're already making this returns array. So like we could make it from higher up. Yeah, you know what? Let's do the other way around. Let's do the mem copy first. I don't think it matters too much either way, but that one's very, like I can just make a very simple program that does that. So for example, we're going to make a thing. We're going to import math just because we have vector 3s. We're going to go produce okay, so we're going to get back a vector 3. Oh no. Wait, yes. X is a vector 3. X equals produce, right? So even if we just do this, that function is going to look bigger than it needs to. Yeah, like we do a mem copy. We say return this into v1, which is 12 bytes, and then leave v2 and mem copy the v2, right? So in reality, what this just should look like is first instruction should be leave v2. And then this instruction should just be return into v2. That's it. Stack of our procedure would be smaller because we wouldn't need space for this, right? Stack size would go down. And we wouldn't have a mem copy, which is -1 instruction, which will improve our Weissman score. And also just less runtime overhead, right? Right. So let's do that one. That's a very focused thing to do. And then the infrastructure that we do for that one will be similar to the infrastructure that we need for the other thing. So the question is, do I make a how do we get the information to where we need it? Because one thing we could do is hard code. I mean, I guess we have to. Anytime we're assigning or declaring on a procedure call, we could have placements for multiple return values. Actually, I'm surprised that we don't catch this in the one return value case like I have here. Actually, no, I'm not surprised. No, I'm not surprised. Okay, so when we have a procedure call instruction, I think in the type checker, when there's multiple arguments, we say stuff like, here's the number of return values received. Okay, let's, there's going to be two separate cases. Declare case, assign case, all right? And this is going to be assign case, and declare case looks simpler, but it should have the same extra copy in it and stuff. So here's assign case, here's declare case. Yeah, they look exactly the same. That's no surprise to anyone. Well, it's a little bit of a surprise because anytime that I'm right about what's going to happen, that's pleasant surprise. What was it like programming on Oddworld? I mean, it was a long time ago, man. I wasn't on that game for super long. I was only on it for like 3 months. You really want to ask Charles Bloom or Thatcher Ulrich or Andy Smith or Ignacio Castaño or some of the other people. Which Oddworld game? I was on Munch's Odyssey or whatever the hell that one was, but that wasn't even, that was like the game that they were doing to just get to the ambitious game, which was Stranger's Wrath, which I don't know anything about at all. Okay. So we have declare case. We have assign case. They both have a mem copy. You know, if we only do this mem copy today, that's great. I mean, it's not as great as doing the other thing too, but like sometimes I just start streaming and all the will to live leaves my body, and that's how I feel right now. It's a very weird phenomenon because I was hyped to stream. I came home, I was like, yeah, I'm going to stream and I'm going to do, you know what? Some caffeine might help with this, by the way. Don't you think I should do some calf? By the way, I bought so much honey at the farmer's market today. I bought like 7 honeys. 7 honeys. It's crazy. Okay, so we need to detect okay, this is when we generate code, for example, for a compound declaration. The assignment version might be easier. Oh, no, because they both, no, it's all compound declaration now. Oh, I simplified that. So this might be better. It's like 3 whole cups of tea, I know. One of them is a larger jar. Tried to play the earlier games, did not like the first one. There was Abe's Odyssey and then Abe's Exodus. I think there was also like an Abe's Odyssey expansion pack. It was Abe's Odyssey, Abe's Exodus, and then Munch's Odyssey. And then Stranger's Wrath, something like that. Have I ever found a dead bee in my honey jar? No. I'm not a communist. Okay. Let's yeah, it always surprises me how much honey there is. Like, how do the bees make all that honey? All right, yeah. I'm going to make some tea and we'll have some carbs and then we're going to dive in. So the deal is here where we do compound declaration. Oh, yeah, we have to do this for, okay. I thought I was going to have to do some weird monkey patching to make this happen. But we have to do the RHS evaluation. Okay. Okay. This is not so bad. I think what we do is we say if evaluate bytecode from is a procedure call, then we could put the placements on that call. We could say get placement for each declaration. And then that might be redundant with what's in emit declaration. So we're going to look at that as well. I have to try royal jelly. I don't know anything about that. That's just from video games for all I know. Isn't that like a Spelunky thing? All right. I'm going to start the water going. Back in a minute. I got so much stuff. I got mango caramels from the farmer's market. In very crinkly packaging. Very crinkly. They smell like mango caramels. Okay. No, we're trying to get the Weissman score down, not up. Down. The score must go down. What are we optimizing? Number of bytecode instructions in Sokoban. Okay. So we're going to use even more fucking memory than we already do. Here, dude, procedure call is so fucking big. Do we even know what a fucking value placement is? This might be bad. This might be one of those C++ times where we're very sad. Fuck. All right. We need to fucking put this. Because you can't, C++ doesn't understand anything. We might have just an incredible chain reaction of like all these things not being known. This is why C++ is a fucking sewer. I just heard the tea was boiled. All right, so we probably don't know linear allocation. But that's a pointer, so it's, oh, no, I guess we knew everything. All right. Success. That was less painful. I mean, it makes the code messier, but at least we didn't. Guys, like, this is a 60 hertz monitor. I'm just moving the mouse around, and it just seems so shitty and slow now. I don't know what Windows 11 did. No, this is Windows 10. Have they been patching Windows 10 to be worse? Like, I don't know what it is. Took a little longer because the water wasn't heated all the way to boil. It was on a lower setting. All right. So we got value placement. We've got this on procedure call. Okay, so okay. So we're going to do cowabunga oriented programming. Oh, hardened. Right. I forgot about that. I want to double, triple check before I do this. Because so what do we do with the poke return value? Okay. Okay. Yeah, okay, this kind of sucks. Oh no, no, this is fine actually. No. This right here. Wait, no, that's just, okay, hold on. This is doing the mem copy. Base plus index times 8. This is just where it has to be stored in our procedure, which is fine. Here we're just moving the value. Yeah, okay. See? Well, okay. This is like yet another copy that's in the machine code that could be elided. But the part that we're thinking about, which is the mem copy part, is partially here. But this is not the part that's the problem. Well, I mean, there's so many optimizations. There's like many separate optimizations that could happen. This could be optimized out as well if we knew that the source address of this copy was also a local variable, right? Because then you just use the target. We're not going to worry about that one right now. It's so confusing, guys, making a compiler. There's just things. There's things going on. So poking the return value is just staging it. Like, and what I was just saying is we might be able to optimize away some of this staging. But then return. Oh God. Yeah, return right now jumps to a post amble. Wow, this is really so we're patching the branches for all the return positions. And then we're like flushing registers and shit here or something. Epilogue begin. But then there's nothing there ever. Okay, now I'm confused. This is one of these things where I wrote this code originally. Some people have gone through and added things and modified it and all that. And so it always takes me a little bit to figure out what exactly is going on. SVN blame time? Not really. Not really. I'm just trying to figure out, oh, this T came out weak. Might have to remake it. So we're doing all this restore callee save stuff. Company you work for is fully Microsoft dependent. Why? Why do you work there? There's a whole world full of other things to do. Microsoft is here to say, so does IBM. It doesn't mean anything about IBM is any good. People thought Unisys was here to stay. It's not here anymore. Dude, Unisys was fucking massive. Watch out, don't make a crazy face after the word Rust. You'll get attacked by crabs. All the crabs will attack you and say that you need a code of conduct. Did all that stuff get resolved about how, like, you know, if you use Rust, you have to let your girlfriend spank you every week and whatever? Like, did that work out, or is that still how it is? Okay. It is basically a soap opera. What is the latest episode? What is the latest thing that they want to control? Like, are they going to require proof that you voted for Biden in 2024? Okay, the carbs are helping with my brain state. Rust isn't really much more than a feature set on top of C++, you're saying? That's not really true. The reason it's not really true is the following. In order for that kind of borrow checking stuff to work, as well as lifetime tracking, it uses what's called the closed world assumption, right? Where you need to be able to reason about the program. And the reason those things are in there is to help the compiler reason about the program. That's why lifetimes are marked up. That's why you borrow pointers and stuff, right? If part of the program doesn't do that stuff, you no longer can reason about anything, right? Which, you know, is makes those features useless, right? Which is why they have to apply everywhere. Because as soon as there's like one function that could do anything it wants with a pointer, you have no guarantees across your program anymore. And that's why they're so authoritarian about everything. But, you know, I guess with like unsafe or whatever, it's up to the author of the function to maintain those invariants. And it's just, you could say, well, the rest of your C++ program is like a giant unsafe, but like as the proportion of unsafe code goes up, like you just, lose your guarantees very quickly. Like, it doesn't make sense anymore at some point. Let me put some honey in here. I got to use up the old honey so we could open some of the new honeys. Actually, let's use a new honey. Let's have some fun. Today I tried this vanilla bean honey and it was so good. Can't register Rust packages anymore without it having any code to which the community went up in flames. I don't understand. That sentence is conjugated in some way that I don't understand, but oh, there's a giant vanilla bean inside the vanilla bean honey jar. Increase the restrictions for creating a new crate. Well, you know, that's the thing. They want to control what you could say on social media and whether you have a bank account and whether you could write code. So, rip. Why do they think that that's a good idea? Let me guess, it's about safety. It's about so you can trust any code that you pull down. Every English word name is squatted. Yeah, I mean, that's to be expected. Name squatting. Okay. Yeah, I would have expected safety, but name squatting, it's a good enough excuse. Okay. This code right here doesn't look like it has anything to do with returning values. Neither does this. Neither does that. Makes me sad. Okay. Okay, here we're looking at the returns. And saying, what's the local register? Okay, here we are passing in parameters. We're passing in just the L values of the memories. Okay, so we could do the memory optimization that I'm talking about without worrying about the register. I mean, the register optimization, I still don't understand where to put it. We'll look a little bit more. But here we could have storage for big return value, or pointer, pre-existing pointer for new big return value. It looks like it's here. I don't know why we're looping. I guess we're spilling stuff. Stack to register moves. I see. So for each return value, where are we, by the way? Okay. Yeah, for each return value, this is for stack. Like if this is not in a live register, we do this. Yes. Okay. So this is like writing those things. Yeah, this needs a lot more commenting. So next time we come back, if we go do this one, we will fucking comment heavily. But for now, we're just going to do the memory thing. Okay. We're going back here. Remember this? Okay. So if here, when we're here, we're just going to say if we don't have the procedure call anymore because this is called from multiple. No, literally. Literally only called from one place, right? Yeah. So let's just reduce the number of parameters. Like, so, you know, sometimes in programming, these things go back and forth where you want to generalize to do this in places that maybe don't have a procedure call struct, and then you don't need to do that the same way anymore. So proc expr is just like call procedure expression. Where'd that come from? Call resolved procedure expression. Let's just do this. These are the original arguments, and this is the new ones. We have call. Oh, there's a placement already. We just ain't using it. We just ain't using that juicy placement. All right. So call okay. Gonna do that. Sure, I messed that up. Also, I think I have my incomplete. I started typing some code, right? Maybe. Great C++ error messages. Thank you. Thank you, developers, developers, developers. Wait, I have a colon in here. That was all. I had a colon. Developers, 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 developers. So this passes a placement up. In theory, we pass the placement. Okay. Let's just check that. Cowabunga-oriented programming. I feel like that will go off a lot. Oh, we're building the wrong compiler. I was about to say nope, but we're running the wrong compiler. Oh. I broke something. That's okay. It's part of the... Ladies and gentlemen, Visual Studio. Okay, that time it appeared. Don't you love how blurry all this shit is? Why is it so blurry? It's only the year 2023. Okay. Arguments 5. Interesting. Oh, this is wrong completely. Let's do this. I goofed. Gang, gang. Ice cream, so good. Okay, that's a lot of cowabungas, guys. That's Cowabunga City. Okay. So now I believe we're not doing anything with that placement besides cowabungaing. Yeah. The return register base is a thing, but like I said, the biggies. Okay. Okay. If we were going to cowabunga, see, I kind of want these to be by value. But then you can't check the satisfied on them. We'll just make it by pointer for now. Guess what? Okay. placements. Oh, it's called return placements. I've been working on your project for years, trying to get an MVP done. At this point, your goal is just to finish it. However, till you feel totally burned out, don't even want to open the project source code and look at it. I mean, yeah, like I've been there, man. I've been there. Taking a break is okay, but it's not really going to solve anything, right? Taking a break will help a little bit. But the thing that will actually solve anything is finishing the project. And this is actually an important inflection point in your, quote, career, unquote, because one of the best antidotes for burnout is success at what you are doing. Because burnout is a way of the rest of your mind that's unconscious getting you to stop doing unproductive things or things that are not necessarily good for you. Things, right? So the way to prove it's actually okay is to succeed. If you fail at your project, you're going to have a harder time. You're going to be more burned out for longer. Okay? So this could be a difficult message, but the best thing to do here is succeed in a reasonable way. And the best way to succeed in a reasonable way is to look at what is going on with your project and make serious decisions about how do you get done? How do you get done in the most efficient way possible? With nothing extra. Because you just got to, it sounds like you've just got to get there, right? Now, maybe part of the reason it feels hard to carry on is because you're carrying a lot of assumptions about how you need to do things. And those assumptions are a bummer. Maybe you need to debug something that's like hard and it's not working all the time or whatever. Maybe your game doesn't need that thing. Maybe it does, I don't know, but maybe it doesn't. Just take that seriously. But yeah, I've been there. I have been extremely burned out. And, you know, one time I got burned out and our project essentially failed. We had to shut down the company. Like, we had a running game though, so it didn't fail in that regard. But it just wasn't successful and it wasn't as good as I wanted it to be and all these things. And I was burned out for like 4 years. It's not good. Yeah, I mean, it's hard to say more than that without looking at your specific thing. But okay, so sometimes when you're bummed about a project, being bummed and sad about it comes from assumptions you have that you're not questioning about how it has to be done, how much longer it's going to take to do it, whatever. You can radically change those assumptions. Okay. And that might, maybe not, but it might put you in a better mood and give you more hope and stuff. Because you're like, oh, wait, I thought no matter what, it was going to have to be this way, but actually it could be this other way. That's my best advice. I mean, you also could just Another thing you could do is postpone the project for a long time, like a year or something, and do something else and come back to it later. However, a lot of people who do that never finish the project. So that may not be good, right? I mean, here's on the plus side. If you've put 3 years or however much you were saying, let me go back and look. Well, you said 4 years now, four FOR years. That's a long time. Most people don't work on programming projects for that long. So on the good side, just keep in mind that you've already gotten further than many people will ever get. So you might as well just go the rest of the way, because otherwise you're just discarding all that work that you did, you know? But yeah, no, I mean, it's hard. It's hard to really give advice. I mean, I've been there. I know how it is when, like, I got burned out enough that, yeah, I couldn't program after Braid even. So before Braid was when I was burned out for like years at a time. After that, I mean, I worked hard on Braid and I got burned out again. And like for like a couple months after Braid shipped, I just didn't want to program at all. I couldn't deal with programming, right? It's like if you get sick from eating a certain food or drinking a certain alcohol and your body just doesn't want to do it anymore. That's how I felt after Braid shipped. But that burnout did not last very long because the game succeeded, both in terms of my personal goals and then, you know, financially it allowed me to go on and make more games and stuff. If I had done a worse job at that game, or if I had gone 3 years and then canceled the project, well, first of all, my entire life would be different because I wouldn't have had a successful project. Probably I wouldn't have never made The Witness, right? Or the current stuff that I'm working on. I might just be a much less effective program. I mean, look how effective I am on this stream. It's been an hour and a half. I've typed 5 lines of code, but you know, my life would have just gone a lot worse if I didn't knuckle down and finish that game. So that just take that as more information. Well, nobody can say for sure how things would have gone, but it's Saturday night. I know it is Saturday. That's basically good. It is, but like at the same time, I'm trying not to give a definitive answer because I think this is different for everybody depending on what their personality is and what their history is and where they are right this second and how they're experiencing burnout and stuff. The burnout is very serious. Yeah. That's I don't know what else I can say. Yeah, I mean, you know, when I was burned out, I was trying to make money as a game contractor and stuff, and I'd do a crappy job on people's projects because I would be excited about the project for like 2 to 6 weeks, and then I would just flame out spectacularly and not be able to type any code, right? So that felt really shitty and led to more burnout, right? Because it's like, oh, I want to do cool stuff, but people pay me to do cool stuff, and then I kind of start to do cool stuff, and then I fail. Like more failure will burn you out more. So you want to be careful. You're having exactly this with all the Unreal Engine projects. Yeah, I mean, dude, Unreal Engine is it's on the one hand, can be very impressive in terms of what it puts on the screen. On the other hand, the work. Whoa! I just yanked my. I was trying to adjust my microphone and it came off the desk. On the other hand, the workflow is often quite terrible. See, I was doing pull-ups this morning and I got so strong that I pulled the microphone off the desk. Okay, it's reattached. Yeah, so here's the thing. Some people say they could be productive in really slow environments like that. Like, oh, just think about what you're going to do next while you're waiting for the recompile or whatever. But I never could work that way. You know? Have I done any streaming on YouTube? I have not. YouTube didn't really do streaming back when I started streaming. And I just, once things are kind of working, I don't really revisit them that much. Working as a contractor, what was that like? More stressful than a permanent employee? No, it's less stressful in a lot of ways. I mean, the thing is, the company is only having you around for a short period of time usually. They could fire you at any time without even blinking. You know that, and they know that. And it's actually a lot more relaxing in some ways. The thing is, it really helps if you have very good contractor skills, which are different from employee skills, and which, if I had realized more explicitly this fact, I would have done better as well. But just like be very good at setting expectations, communicating progress, communicating when things are taking longer than you expected. If you're going to take vacation days or something, tell them about that well in advance. And you could do pretty well. Yeah, I found being a contractor way less stressful than being an employee. As long as you're not worried about people firing you. Okay. Right. I guess we're going to make sure this doesn't crash anymore. Hey, look, it doesn't. So, right, our mem copy is still there. Okay. Now, in the value placement, we have this thing. Wait, no. Oh, no. No, it's in the procedure info. Where's procedure info? There it is. So in here, we have this returns. Those are return infos. See, but for now, we are keeping them separate to minimize confusion and bugs. Okay. value number target destination all right. Okay, so now we have to look for people okay. So here we're gonna, this is the very thing that we're looking at, right? Yeah. So here, if we have a placement, we're gonna use it, but we're not gonna do that yet. Because what we're gonna do here is say, if placement set this other member that we just added, otherwise do this linear allocation. Well, yeah. Okay. So here, this is to check to see that a call is the same, right? Okay. So we need to add this in there. So the two calls don't match if they're trying to return different value numbers for big thing, including, okay, 361. Bytecode printing. Okay. Okay, else if it dot not equal to -1, we're going to say this is confusing. Okay. I feel like that's going to be a little bit redundant, but all right. So we put that in there. His handmade hero coming back. Well, he's doing computer enhance now, which might be better for a lot of people. Okay. So that's the bytecode printing. I'm just searching through the code for everything that used the old dealio. See, now I'm confused because it looks like we don't need the thing that I added. Oh, no, okay. See, local register is a confusing name because local to who? This is for L value only. Okay. No, that's for our values. Okay. Anyway, anyhow. Okay. So here we're going to say I can't name something return in C++. Tried to do that. That would have been a goof. Okay. If value number for big return value destination address is not equal to -1. I want to do this. Dest equals not new record, old record. Old record registers this dot pointer. See, so we have it there. It's fine. Wait, where are we mem copying? I guess that's fine. I guess that's fine. Because, yeah, we don't do the other end of that placement right now. I don't think. Maybe we do. Return size. Oh. Where's that? Okay. So now we're still going through this. Okay, so if that, else, what did I just do? Okay, this is a lot of work actually. Not even done. I expected it to be less of a hassle, but this is what happens with a compiler, right? Okay. This would not affect anything yet because we're never assigning this, but we're just double checking. Okay, we're still going. Inline. Okay. I think we don't have to change anything there. Oh. No, we do. Okay, new arg dot this is remap vn it dot this value offset. Okay. Yay. Okay, LLVM converter. Let's just make sure that compiles first. Okay. Yeah, this is fucking stupid. Okay. Okay. So we're saying create store into a stack Iloka. How does that work? Dude, I hate everything about LLVM. Hate it. Hate it. Hate it. Why don't I use code autocomplete? I don't see a reason. This is just a typo that I keep doing. Why does the compiler handle big return values using some separate storage? Because this is a thing that you could take different policies on when making a compiler, right? LLVM does a different thing. It says, hey, if you have a local variable or a parameter or whatever, regardless of the size of the thing, we're going to have those all have memory regions associated with them. Essentially, they're all always on the stack. And then if we want to optimize them out of being on the stack and put them in a register, that's an optimization that we do with this pass called mem to reg, right? Here, we do it differently because I don't want to lean so much on that kind of a thing. Even though, I don't know, you sort of do anyway. But what I do is I say, look, the calling convention is different. If you're 8 bytes or less, you fit in a machine register. So we just treat you as a value like an integer, basically. And if you're more than that, then when we pass you around and stuff, we pass you by reference, right? And so why? Because there's a lot of reasons. We actually have some documents explaining it. I'm not sure I want to try to do all that right now. It's a decision about minimizing when things are copied, right? So in C and C++, when you pass a parameter by value, it gets copied, and that's like really not that good of a thing. But basically also, so in general on a CPU, a register sized value is very cheap to manipulate, right? It's a register to register move if you want to copy it or whatever. A big value could be arbitrarily big. And so copies of those tend to be more expensive, right? It's the way I decided to do it. You could do it several ways. Okay, wow, I might need more tea. Are big things copy on write? No. I thought C++ had a register keyword. The register keyword in C and C++ does jack and shit. It only mattered for like a couple years in the late 80s or early 90s. Compilers completely ignore it now. Okay. So I have to figure out let me just do this. I'm just going to make this slightly more terse. So we're storing stack alokas in parallel. I think this thing being called registers is misleading. I think, well, I don't know. I don't know what that actually is. Wait, is this when we're calling a procedure? Yes. Okay, what about pain? So what is arg's value? So we're going to want to do something with registers sub this. Okay, and we're going to want to do something with something like that. So we say stack alokas and then we say create gap. I just don't know how to do anything in LLVM or in anything else. So this is already a value. I think I could just use it. I think I could just use it. We're going to go forward under that assumption. Okay, that's it in LLVM, thank God. X64, last file. SRAT index. Fuck. Okay, how do I load? Do this. Okay. Fucking goddamn it. What is this? Commit code for procedure call. I see. Why is there Oh, that's passing in the argument. Yeah, never mind. And then this is... No, we're still... This is just... more argument passing. What is going on? Oh no, this is returns. Okay, this is some C calling convention crap right here. All right. Okay. So we have some temp variable. And we're going to pass that. Okay. All right. And then here. Okay. Oh, not large return offset. Fuck. We could just not do this for C calls. Oh, we can't. We can't do it for C calls. Let's just do this. Okay. Which means the SRAT thing. Okay. Well, we're at the point where we could actually maybe turn on the thing, because in theory, all the sites that handle return values know about this, although it's quite likely that I screwed those up. But if I did screw them up, maybe at least one of the three backend pathways works, and we can use that to validate that the earlier part works and then figure out the bugs. I'm going to warm up more tea water. Ice cream, so good. Okay, while we're making tea, I'm going to put my laundry in the dryer and start the next laundry in the washer, and that's going to take a minute. So if people want to line up questions, if you want to take time to type in questions, then I could ignore the questions and not answer them, or maybe I could answer them. How's it going? What flavor? Okay, I feel like nobody has good questions. I feel like that is what we are discovering. In other languages like Go, defer adds a 150 nanosecond overhead. Does defer in this language have a similar overhead? No. No. It has no overhead. Why? What is the source of that overhead? Okay, the clothes are going. Now I got to do the tea. I suspect, so depending on how you try to do defer, like I don't know what the semantics are of defer and Go, but no, actually, I don't know. Are we going to play any games? We might play Xenonauts too. I believe it defers to end of function, not scope. Yeah, but that, I mean, that just would change where you invoke the code, right? You would invoke it on returns. I mean, maybe due to the way that the semantics are, maybe they have to do it more dynamically for their feature set. Like it might actually be that there's like a linked list of defers that run or something, like actually dynamically in the function. We do not do that, but I could see that that could be the implementation. If I couldn't afford to hire artists, how would you go about developing a game that could still be appealable to a wide audience? I mean, there are examples of such games. Go look at frickin' Undertale. That dude didn't hire an artist. The overhead was a bug. Okay, there you go. There you go. All right. I'm going to go make the tea. Back in a minute. Yes, I am completely out of the Florida apartment. All right, well, nobody has any good questions, so we're sad. We are sad. Nobody cares. All right, so it's time to try to set the variable. There we go. Okay. Call. How do we know that? We probably have that already. Okay. Get placement. No. Plug L value. Aha. Plug L value. We're going to assert that the offset is 0 temporarily. Placement, comma. No, check in, do this for all returns. Oh, fuck. This has to be I is equal to 0 for now, because, you know, we made that, we put the placement in the placements, the return placements array, but we're not putting more than one placement in there. And, well, okay, we can change this if to something better once this is done. Offset is equal to 0. Cowabunga. So many cowabungas. Oh, we got offset is equal to 0. Assertion. Wow, this is kicking in a lot, which makes me nervous. Let's make it only happen. Because if something's broken, like the entire program is just going to be frickin' destroyed, right? So we're going to make it only happen on line 32. All right. That way, we also don't have to handle that offset thing yet. Okay, well, it didn't fix anything. In fact, we didn't cowabunga at all. Oh, because it's line 12, not 32. Where was I getting that 32 from? All right, we got a cowabunga. We're still... Oh, no, it worked. Guys, look. We got rid of the mem copy into existing L value. Okay, so does it blend? Do we print the right thing? It works. See, we did all that and it works. Should I pour the tea yet? I don't want to be up for a million hours tonight, but at the same time, it came out weak sauce earlier. Where's my cup? Oh, there it is. Is there a chance that we lose that L value? What do you mean lose that L value? What do you mean by lose that L value? Okay. Yeah. Yeah, this is what we want. Now this part, what the fuck is V1 for in this case? Right? Like, why are we allocating V1 at all? That seems like a relic of old code, etc. Like, we're obviously not using V1 literally for anything. So I think it's just a very old vestige. So this is still 56. This is 44. Our stack has gone down because we're no longer making this temporary. Right? So that's good. So this offset case, we need to fix the offset case so that this will run on anything, right? Can we plug L value with a null offset? No. Okay. If offset we do something. Instruction binop add, or whatever that's called, L value. Oh, add binop with constant. Add L value offset. Binop add, what's it called? Bytecode binop. Where is it? It's called bytecode binop plus. Line 6049. We don't say L value equals. Okay. So that's still working fine, probably. We could go here. We can comment out the print. Oh, did I? It's no longer line 12. But that's okay. So it's not happening anymore, but we should hopefully be able to delete this one. All right. Okay. So we got tons of cowabungas. If we go back here and turn the prints and the revolution back on. Why am I recompiling the compiler? Oh. Oh. Fuck. Okay. Well, something's broken. That was no surprise, though. See if that works. Okay, the compile time execution version works. Let's get rid of the cowabungas now because they're just loud. All right, x64. Okay, there we straight up crash. Okay, LLVM crashes at runtime. Okay, let me pour my tea before I create an international incident. This is not really a surprise. This is going as expected. Does plug L value check for a non-null pointer? No. No. I don't know how to answer your question because no, you would only call that if you have a value placement. Ice creams. Okay. Ice cream. Okay, so we have two different crashes. Compile time crash, easier to debug. So we're asserting wait, what? That looks like a wrong assert. Hold on. Oh, because it's a C call. By the way, this should just exist. Fucking amateur ass code right there. Okay. If it's a C call, oh no, yeah, it's a wrong assert. It should be that it's equal to -1. Bro. Okay. Oh, now it's assert. What? Oh. Maybe it's void C call returns, but I would rather return typedef void in that case. Okay. Hey, ice cream's so good. So this is working with x64 backend and compile time execution. Not for the assignment case yet, because that's not passing the placement. And then after both of these work, we're going to want to do going to want to do multiple arguments. But you know, we could actually always fucking use this slot. Like, I don't know why. Okay, well, compile time execution is failing in some case now as well. That makes me sad. Like right now, I'm passing the linear allocation in. Yeah, we could just do that Lee ourselves and just always have it be the thing. But we need to get the thing working everywhere first. There is an additional complication, right? So maybe bugs are in the code that I just wrote in terms of the menial operations it is performing, or maybe bugs are in the concept that I could do this all the time, right? Like what if for some reason we're not allowed to always elide this copy? I'm not thinking of such a reason, but that doesn't mean there ain't such a reason. Well, so we still have at least 2 bugs. Here's what I want to do. Like I said, we could just do the Lee ourselves. And, in fact, we could do that 100% of the time. So here, I could like comment out all this stuff. This is what we want eventually when it's working, but I could literally do this. We need to not uniquely, okay, we did that. Okay. Oh, wait. Yeah, inlining is going to fuck this up. That could be what's messing up Sokoban as well. See, if I do this, this isn't going to work with inlining. So I don't want to try this. It seemed like a good experiment. A ghost is staring at you in your room. What to do? Say, gang, gang. Ice cream so good. Dude, 600,000 scoops of ice cream in a month is 20,000 a day. They would have to be very, very, very small scoops. 1 million calories is enough for a year. Well, you know, the Rust Foundation says in order to use the Rust programming language, you have to agree that there's nothing wrong with eating 110 million calories a year because, you know, I mean, the thing you would have said 10 years ago is that body shaming is bad, but now it's that even though body shaming is bad, if you're not body shameable, you're a white supremacist. Something like that. Okay. Code shaming is still allowed? Well, yes, of course. All right, so I don't like these bugs that we saw. They could be very annoying and difficult. The LLVM one is probably not that hard to figure out, but it's probably horrible because it's fucking LLVM, dude. Okay, so that works fine. Let's just not support LLVM anymore. Problem solved. So that's -1. Which is what goes in this thing if it's not set, but I don't necessarily feel that that's the problem. What was this even called? For big return value, Okay. So it's literally this. I don't know how you can do create store with a loc. That's right. Okay. I think yeah, so this is doing the same thing as this down here. I kind of just want to see where it crashes. You know? Oh, not a local folder. is this so busted? What is going on? Okay, print item to builder, print float, any dot value pointer. So I'm guessing that any is hosed. The value pointer is hosed. The value pointer is going to be a -1, right? What the fuck is going on, dude? Okay. Yeah. Well, that's a float -1. Okay. Yeah, this is weird. This is not FFFFFFFF. See, here we have this float. The float is stored in the pointer slot. The pointer is supposed to point at the float. So I done fucked something up. Let's just look at what it does with args. Because sometimes I just don't read the code. Create call with args.data, args.count. Okay. All right, so here we needed to have passed this. Okay. create store, load res from Reg, from Reginald. Yeah, we're trying to streamline when functions return large values. And I had actually hoped it would have been easier than it has been, but you know, this is just what happens sometimes. See, here we're doing a mem copy. It's a large return value. The source is the address of the vector 3, the first member of which is 1. So we're mem copying from that into the value pointer of the any somehow. This might have something to do no, so everywhere where we read this variable, I should have found and no, the any is just a thing. The any is what's crashing on us in LLVM. This is for any, this is for all return values that are large. I mean, it probably can't be a bytecode level, but, oh wait, what? Oh, we've got it open in the debugger, so we couldn't write it. So the LLVM one is still there. I was like, wait, what? What? No. Yeah, it's fine. I didn't notice for a second that those were different numbers. So I was like, wait, they're the same. They're not the same. They're not the same. All the things we do just to pass the varargs. like, I don't even think the problem is in our particular code that we're trying to test. Like, if I just do a sign case, I bet it still happens, right? Oh, we got to close this for a minute. Yep. So it's not actually this one. It's like, because this optimization is enabled for general things, somewhere in the print code, we are doing the bad things. What happens if I just don't do the printing again? We may still crash, or not. So that happens to get to the end. Can I print a float at all? Huh. What if I print 42? Uh-huh. So the value is wrong. The value is wrong. Which we expect. We're sort of verifying that. Okay, they're all not being written to. I mean, we could step in there. It should be pretty simple code. It's just probably still confusing. So let's try stepping in. Let's fix these because the indentation is awkward. This was what I saw. I was like, eh. Going to go into the file. Going to go to here. We're going to run. We're going to step down. And we're going to Control-Alt-Shift-D, Alt-Shift-D. How do I do disassembly? Wait, what happened? It's the wrong Visual Studio. Wait, the other one closed? Where'd it go? Does Control-Shift-D close Visual Studio? Dude, it starts at like half on one monitor and half on the other, and it's just giant. Debug Windows disassembly. Control-Alt-D. That's what I tried to do. going to call this function. Oh, we just crash when we step in. We crash Visual Studio completely when we try to step into this function. That's what happened. It wasn't my Control-Alt-D. It was the high-quality IDE called Visual Studio. Well, okay, that's not working. So it really doesn't like this code. What do I do? Like, this is just confusing is all. The mistake is probably something very small. Here's the thing. There's the poke return value. Let's check that. Okay, we're never calling poke return value. Wait, yeah, we are, right? We're not. Okay, hold on. We need to dump produce. Okay, yeah, poke return value. V2 into return value 1, which is fine. We lee and then poke it. See, this might be part of the problem, is this fucking confusion here. Because like I wanted it to be working and then I would fix this bug, but like that's probably kind of the problem in at least some cases. Right, so this reg is either the this is probably the dest, right? Base poke return value dot ret index. Base is my return value base, right? See, this is very sus right here. This is fucking bullshit code. Poke return value dot ret index. That's just going to be 1 in this case, or maybe 0. Yeah, because we probably print it with a +1. So this is going to be register sub base, a sub base. We're going to mem copy to base from load res So this is, okay. So the question is, this gets set up probably on procedure entry. Okay. Yes. Okay. Yeah. That's the problem. So this is being set up based on the argument info, which, like I said, is different than the return value info. And that is bad. So we're shoving this result into that V1, which doesn't exist. At least that's one of the problems. One of the problems. Let's go back to that code. Thankfully, this was grabbable. Okay. So let's just fix that part. That's easily fixable. So if I just, if I just go back here and we just don't do any of this. We want this to match that. And it does not. So I guess we're setting local register always. Let's just for a minute do the following. Okay, well, that was a disaster. That didn't work at all. I'm not sure why. So this looks like it was some doing get base name and path in the build program, and we're crashing. You know, I would like all this stuff to be simpler. I would like to be there be fewer things about how it works. And maybe this is how we get on the path to there being fewer things about how it works. Because that's how you know. It's cases like this when you sort of learn like, oh, this is actually more inconvenient and complicated for what I would like to do. Dude, I want our Weissman score number to go down a little bit. And that's not going to happen if I don't fix these bugs. You know? This is one of these things where it's just confusing. Like, possibly the right move to do is to turn this off for a little while so that we're back hopefully to everything working, because we're never employing this. And then we kind of need to clean out the difference between these two things. So we've got this arg_it, which is probably some LLVM fucking arguments. Context argument for all the linear allocations. We make an alloc A and store This is very confusing. It seems like we're making pointers to every argument, which by itself seems bad. We might have to do a weekend stream of just like cleaning up this kind of thing. So we're making, see, we're storing arg pointer. No, input arg and store goes the other way. Okay, input arg. That's a C call. What is input arg? It's not literally not anything. What is going on? That's in the C-call case. Oh, this is in the C-call case. Okay. So confusing. All right. Down here, input arg. I think that's literally for arguments. Okay, so returns, we're looking at this again. This is for all the value infos. What about the returns? I guess the answer is there isn't anything. Well, there's the bogus argument thing. Literally just that. But so that just means that when we made the function, okay. This is another instance of bogus argument thing here. We're just passing those as pointers. Okay. Literally one per, because again, LLVM doesn't do non-memory things. So literally all of these go as into memory. Okay. This is the code that we added. We said we get the pointer. We put it in the args. This is confusing. Because like, Okay. Okay, no, I kind of get this. I kind of get this now. It's coming together in my head. It's coming together. So the reason we do this, I forgot about this. I remembered it earlier and then forgot again. The reason we do this is because that whole thing about allocating the registers like from the return value base and stuff doesn't actually initialize the values ever. They get implicitly initialized so that we don't have to generate a bunch more junk bytecode instructions. And so part of the job here is to put put the lotion in the basket. And that's why we are using this. Right? So the L value of this allocation goes in registers sub it.local register. So like okay, now I don't even remember what we were doing. That was, oh, it was this. Gotta turn that shit off. All right. Still doesn't work. That was not right. This is just a confusing thing because like in the bytecode model, there's places that things are during call and return and all that. But then in the LLVM backend, it's got its own, way of dealing with that. That is probably more complicated than I wish it was. Definitely more complicated than I wish it were. But we're not like crashing with FFFFFFFF anymore, although maybe we would be. We probably would be if we did the big print statement like we had. This is not very fun. This is like me every time I try to do anything with LLVM. It's like I just don't quite understand what this backend is doing. It's written with not quite enough comments about important things. I will add comments anytime that I invest enough time and energy to coming to an understanding of the thing the comment should have told me, right? Had an employee tell you that comments are unnecessary. Well, hey, I'm sure that dude knows everything about programming. See, the thing that keeps popping up in my mind as I look at this, on the one hand, maybe I'm doing something wrong with something quirky that LLVM is doing about its own mapping, right? On the other hand, we already know there's a frickin' bug. Aside from that, in compile time execution, because frickin' Sokoban crashes at compile time now. And furthermore, things really crash at compile time if I set that local thing. So here's what I'm going to do. My new policy is I'm going to stay in my own code for a bit and figure that out and get, because we should be able to get all that working because like we wrote it all, right? It's our own model of everything. And then once that works, hopefully things will be a bit clearer and I can go back to the LLVM thing and do some stuff. I feel like it's time to check the laundry. Any questions while I check the laundry? Dryer's still going. So part of this is that the naming of some of these variables is not very clear. Local register, what does that mean? Right? PC load letter, what does that mean? So cleaning that up a little bit, represents forward progress. Try with an older version of LLVM. No, that would take like 3 days. And wouldn't solve anything. Do we have VLAs on the stack? I don't know what a VLA is. What's a VLA? Is that like the MTV Video Music Awards? For losers? I don't know. Variable length array. No. No. Okay. So let's just check to make sure that we haven't destroyed the universe. If we do x64, that runs and gets the right answer. Well, and that's a clue right there, right? So why is local register crashing compile time execution if I assign it to something different? Because that's weird. So let's go to like, actually let me just double check my assumptions like in Memento. Oh, no, we know this because it's right there. It's return register base plus I. Okay. Dest register. This is confusing because these are like different return register bases. Like, what the fuck? Like, like, what is going on there? I don't feel like that's right. So source register is return base plus I. See, this should be happening in bytecode poke return register. Yeah, this is like a whole extra copy that we shouldn't even do. Like, you know what we're going to do? It is premature to try and Weissman score this. So we're going to turn off the Weissman score right now. The good news about that is that we'll do a Weissman score stream later where we actually hammer on the score. What I think we're doing now is we're just cleaning this stuff up. Okay. What about Xenonaut 2 score? We might work on that some tonight. So we're not even going to use this yet. We're back to the old thing, and we're going to make sure this works for everybody. See? We're going to check in the progress. Don't need that anymore. So I'm just going to go through all of this because the thing is, a lot of this code for return values was done in the very beginning of the compiler. And then we like modified it as we went along, but sometimes it's easy to, you know, just sort of miss some modifications, miss some things, you know. I have 3 copies, not 2. I don't even know how many copies I have. It's probably different between the backends and compile time execution. Yeah, probably 3. There's probably like the stack value, the place that goes when we say poke return value, and then the final place in the caller stack. Okay, this is just an Emacs turd file, so that's fine. No, not Sokoban though. Prep for return value optimization. Need to clean up some return value sewer first. Okay. So this return register base thing is a function. This is in the old record. No, that's in the new record. Okay. Wait, what? See, all this stuff. Like, why are we only setting U8 there? Like, what? Just seems totally wrong. Okay, so here, Oh, right. Well, okay. Here's one reason why it may work that way. Because when you're returning stuff back to the compiler, how do you do that? Right? Because if it's a calling function, that function could just have pointers and stuff. Right? That function might have a local variable. It creates a pointer. It passes it in. As one of the arguments. I mean, I guess we can do that here too. I mean, we need to prep the arguments, so this is probably why this started though, was because it's like, oh, we have a run directive. We need to decode the values. I feel like we should assert false here, but if return base goes away, we're not going to worry about that anyway. Okay. Convert register to asked. Right. Yeah, so that's why. So this is a little bit annoying because it means to clean this up and simplify it, which I definitely would like to do. We need to change the way that we return things. Now, fortunately, so being successful at programming, especially in a system this complicated, you need to be able to break things down into smaller, simpler problems. So one way to do it, which is the virgin chump way of doing it, is to go make the change to get rid of this temporary return value area. And then be like, oh my God, I broke all this code. I have to now go fix it. And then you have like 3 weeks or 3 months or 3 years if you work at Facebook of like trying to fucking fix all that shit. And then you eventually get it. But we could do this part separately, right? We could change. Well, you can start with stuff like this and do as much as you can to change the way it works, or like make sure that arguments get passed in that are pointers to these, which I believe they already need to be. And then just use those in, like here we're pulling them out of this area. And I don't think that we should need to do that. We'll see. Is there a book I recommend to learn C++ in 2023? No, don't. C++ is a giant mess. Messy, messy mess. Messy, messy mess, 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 mess. Mess, 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 mess. Mess, 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 mess. Why would you use VLA for such a dumb word? Because it's been a long time since language designers were doing anything useful. So you have to make it sound like you're doing useful things, by making new complicated terms for things that already existed and that were already simple. Would I recommend learning Rust? I mean, if you like it, what's the problem? I mean, I wouldn't really recommend it, but if you like it, go ahead. What do I think of the Godot engine? I don't really know hardly anything about it. All right, I think my laundry is finally done. If there's any more questions, you could go ahead and stack them up there. But I'm going to just keep clicking through this. Argument register base plus, yeah. This part might be fine, actually. I don't know what the fuck is going on here. I don't know why this assumes two things. Oh, because it's a modified, okay, modified directive. Never mind. This is a bool and resulting value, or what do modified directives return now? I think they just return bool, right? What do we return from modify? I think it's just, oh, because it's a string. If you fail, you return a string that's the reason why you failed. That's what it is. How do you organize your workforce? We don't really use very much of that. People talk on Slack, but it's more like casual. Okay. So this is weird because on the one hand, I'm looking at the return register based stuff and I'm like, oh, kind of makes sense to do it this way, actually. On the other hand, it's not, nobody else is using that, but they may just not be using the function. When we poke return value in bytecode runner, we say get return register base. Okay. And we literally do a register to register copy. So we're at least not copying into like extra target memory or whatever. But if we wanted to make this clearer, we could at least put indices of the return values on the call record instead of copying the registers. Okay. That's poke return value. And this is fine because if this is a pointer that points to a big value on the stack, that memory still exists, right? This might be why the local register thing was crashing, because we're overwriting the value. Oh yeah, that would do it. That would do it. So this is not kicking in yet, so it's only this. And we're assigning the pointer, which is not redundant. But this return size is down there. So the actual when we do a procedure call, we do hardened. Oh, no, that's in the bytecode builder. What the fuck? Oh, this is for, that's respec. I was looking at the wrong thing. Okay. Dude, my eyes are glazing over. So we literally don't pass anything in for those, which I guess we don't need to. Okay. I understand this. I'm not sure it's the best way to do it. But I'm not actually sure it's the worst way to do it. Except this, okay, this is definitely not going to work right with our new thing. That is one problem, because we didn't put code here to do the mem copy. But I think that what I would like to do is refactor this to work more like the backends work, because like the backends impose the most constraints in that, like, there's no extra compiler meta information hanging out in RAM at runtime. And so functions need to know how to return values. And so they do it through the argument passing mechanism. And this is sort of also doing that, kind of, but it's doing it in a different way. What I would like to do is change it to work in the same way, so this is less frickin' confusing all the time, right? I think that makes sense. Also, like, you could call elsewhere procedures from here. That might be broken if they return big return values or something, or we might be doing some extra special bad hacks for that. This was not what I had on my bingo card as a thing to be looking at tonight, but sometimes it is what it is. Sometimes it is what it is. Okay. Let's look at x64 backend. Again, poke, return value. So here, this is confusing because of the register mappings, but whatever. We're ignoring ccall. So here, we get the return index. We get the base of some memory. On the stack. Okay, I don't love that. But yeah, this is on the stack. This is kind of not that different from what the bytecode runner is doing. We're loading a pointer. So we're saying this is a pointer. We're loading that off the stack. And we're doing a mem copy into that pointer. All right, if it's big, that's this code. If it's not big, which is this, we're storing the register there, which I don't think fucking does anything. Let's see. Maybe it does. See, if it's not in poke return value, so this just stores it into this procedure's own place. See this, I don't understand. How are we returning small return values in x64? Right? Oh, it's in the code. Okay, that was the postamble for the function, but the call now. See, we already popped the stack pointer. I think we're reading this out of the functions. Like like this is past the stack pointer now. Which I guess is fine because there's like red zone, whatever. Doesn't seem 100% kosher, if I'm being honest. This is all copy pasta. It's literally just these two lines. Okay. See, the thing about this, this is doing some stuff that's bad. Okay. I think, so the thing is, we're overwriting We're overriding the source register with the target register. Okay, wait, when does the mem copy happen? Doesn't the caller reserve some space for the returns? Then there is a double copy, one at poke return value, the other here. I don't really remember. I mean, I think part of what's confusing is it's different in every backend. And I want to fix that. So, you know, the thing that I'm trying to do is allow it so that, you know, if the caller has a pointer to memory on its own stack or memory that was passed into it for where the return value goes, that gets used, right? And it's just all this return value code is so old. Like, it's just gotten more complicated than it should be. And some of that is just maybe there needs to be some function or macro with an easy name that reminds me of what's going on or whatever. But yeah, I'm not seeing, so there's some things here that are not good that made sense originally, right? I mean, they're not like, they're fine for before, but like, so here it's like, okay, we're loading into the thing in the callee's stack, which is just either, so there's no check to see if it's a big value here, right? So if this is a small value, it's the value. If it's a big value, it's the L value, right? So we load that and then we store it back in this function, right? And so for small values, that's fine. For big values, okay. I think for big values, this is a pointer to our own stack that we allocated before the call. And it's very fucked up that we're giving that pointer to the callee and then the callee is giving it back to us. I think that's my best guess at what's happening. And that should get cleaned up. That, like, yeah, that should get cleaned up. I mean, I kind of know why that happened. Okay, so poke return value, if it's a big argument, this is our pointer in our returns area, which probably that pointer is set by the caller or in our preamble. It's in one of those two, right? It should get set by the caller in order for this optimization to happen. And it maybe doesn't. So we load D, we do a mem copy into that. This only works because I don't see a copy out. So this only works if this is a pointer to the caller's space, right? Which means we must set it up here. God, there's so much fucking code, dude. I mean, we're not passing the number of returns here, so I don't see how that's happening. Oh, it's in the procedure info. In which case, why are we passing the number of arguments? Because the procedure info has that also. Okay, here we're just clearing the mapping. Oh, because I guess you might be calling a... This gets called for a callback as well, which isn't going to have a procedure info. That's why. Okay, so info returns. Like, this is weird because we're checking the size, but it shouldn't be mapped if it's size 0 anyway, right? So that's weird. Anyway. That's SRET stuff, which I guess is C-call again. Okay, so here... Yeah, we pass arguments. Right. I looked at this earlier tonight and I forgot. So this is not active. That's our new code that doesn't do anything yet. If we've got a big return value, we take the pointer to it and pass it in. Yeah, so we pass it in and then let the callee write that back, which is not good. We should write the pointer ourselves here and not write it back from the callee. And that allows us to pass a pre-existing thing or whatever. Do we still fix crashes and critical stuff for witness? No. No, almost all crashes on witness are graphics driver problems. And we have no control over graphics driver problems. Like, seriously, 99% of problems with the game are graphics drivers being broken. Okay, so let's try that change. Because that is more sane. More sane. Okay, so here's call time. I mean, this is probably duplicated for C call. And that goes into it.local register, where it is the return info. Yeah, I need to make just a giant banner comment after I figure this out, explaining what the fuck's going on with return values. See, this whole thing that's happening right here is only a good idea if it's not big. We don't want to modify the return value at all if it's big. I don't know why this, well, okay. And then we go past single argument. Okay, but also we're going to move indirect, move 64 indirect, C, temp, RSP, base, we might not have base. Wait, no. This one. So easy to just to do the wrong thing. Oh, yeah, I don't like that this entire thing is a double pasta, but factoring it, I don't know. Yeah, this is, I might be doing something wrong here. Oh, gotta finish that. We got to check this. Also, I've got to check the register mapping. I guess we don't check if it.local register. So I'm just going to say assert. Okay, we're going to move indirect into that, or we're going to get this mapping. Okay. I don't know what this PR to VR, physical to virtual, preg allocate. I don't know what that means. Yeah, I'm just gonna get something wrong here. This is a register to register copy, actually, right? I don't know how to do that. We'll look that up. Temp. Okay, what is this doing? If PR to VR mapping is not this register. So if the register is mapped to a mapping, but the mapping is not mapped back, well, register value number, like virtual, right? If the physical register is not mapped back to this, then map it or something? I don't know. I guess. Okay. If support has stopped, could it be a good idea to open source the code? No. 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 Oh my God, no. Someday we will, but not for a long time. Like, again, the game works fine. So, like, we don't really need to support. There are a couple of bugs that come up for small numbers of people. But for the most part, it works fine. A lot of people still buy it and play it every year and have a good time. May you ask? Because it's fucking paying many people's salaries right now. That's why. like the last thing I want is some Chinese game cloner dude to like start selling The Witness. Also, I mean, here's the sad fact. The idea is that in open source, people can fix bugs and do great stuff with it, but usually that doesn't actually work. Especially, like if I actually thought that was the best thing to do for the game in terms of people being able to play and enjoy it, I would do that. But it's really not. And like there are rare cases where it works. So if you go to like original Doom, you know, that's been ported to literally everywhere, people probably do a pretty good job with that. But that's also a tremendously simpler game than something like The Witness. I don't know. I just don't see open source doing a good job with this thing. Why not the compiler? We will eventually. It's just, again, I don't want to deal with internet Karens, really. You know, it was still making money. Yeah, it's not making nearly as much money as it used to, but I actually don't know the real number, but it makes, probably depending on how lucky we get in sales and stuff, it makes between $500,000 and $1 million a year. Still, which we need because running this company is super expensive. Yeah, we need, like, here's the thing too. Because we've been doing all these projects that have taken a really long time, like The Witness is our main income stream, right? If we had released another game since then, maybe that game would be big enough to dwarf the witness, but that, as you all know, that is not the case. Storage for bit return value. What was I thinking there? Big return value. Okay. I feel like this isn't going to work because of something about the register allocator that I don't understand. But we could see. I mean, we managed to return a big value still and print it. So I guess we run this on the tests and on Sokoban. And if all that works, then I don't know, like we're so deep in the hole right now. Let me get a drink. Braid still makes a little bit of money, but like way less than the witness. Okay, that's just the Emacs turd file. Let's delete that. Okay. Why was I doing this? Well, we also want to check this as well. And we'll explain. Big values got filled via mem copy in poke return value, right? Poke return, yeah. So this is like a lot of code to do that. 2 passes. First pass is on the stack to stack moves. Second pass is stack to register moves. So let's REX into. Let's just do that because I don't want to confuse between physical and virtual register in the comment. I could have this be a 2D loop for j equals 0 to 1. Let's use RSX as a temporary without worrying about a previous iteration using it. Yeah, that makes sense to me because we're, yeah. I guess. I mean, don't we have to like spill RAX before this? Why don't we say spill RAX? I don't know. Maybe the move of the pointer ended up being a no op. Yeah, well, so here's what I'm assuming. Like when you did this, you know, obviously there already was code in place to do return values beforehand. And that probably also was doing the same no op thing you're talking about, right? And so you probably just inherited that, is what I think happened. I mean, I don't want to go digging through source control. I don't care that much. But yeah, it probably just copied it out, and because that's the same, because it's the same value, it's fine. But then, you know, because there's discrepancy, like this field local register, which I named, I believe, is pissing me off. So it's my fault. Like I don't, every time I read that, I don't know what the fuck it means. So that's making this hard. Because yeah, like I kind of know why it's called that. It's really caller. Um, it's the, like instead of local, it should be called caller first of all, right? And because like local to who? um, and then the thing is, I also don't seem to know when it's set. I guess it's set always, and it's either the L value or the R value, depending on if it's big or not, which is not that surprising. That's how arguments work in the compiler. It's just, it's confusing and hard to remember when looking at all these things. And then it gets more confusing when you see it written into like, okay. So I've now fixed that so that that's input only. I don't think that's going to change anything in terms of the behavior of what I'm working on. It's just more sane. It's more sane that it's input only. Hindsight, you probably should have made a lot of this more automatic. Yeah, I mean, honestly, that would be nice because I'm very nervous about what I just did because I don't understand it, and at least if it's like encapsulated, I'm less nervous, right? Because if, like, I don't know if this is what you do every time you write to it. I guess so from your description. I think so. But when I did it, I was like, okay, oh yeah, this move here. I guess that's right. Let's check it. Move 64. Okay. Yeah. Okay. Sounds like we are supposed to do this the first, if it is possibly the first time we are writing to this mapping. Normally handled by vreg write. Okay, so because we're not vreg writing, because we can't, or could we? I mean, mapping just comes from, I mean, couldn't I just vreg write this? Wouldn't that be... There is no vreg right. Vreg finish right. I mean, it's doing... Oh my God. So vreg prepare, do the move, and then vreg finish right. This looks complicated because this is made for instructions specifically, right? It takes that array of like the things. All right, I'm not going to worry about that for now, but it does feel like it would be nice to clean this up. Okay. So now at least I understand on x64 how it's working. We could check LLVM as well. It might be doing the same thing. And then bytecode builder could be fixed. God, look at all that. Look at all these libs. I sure am glad they factored LLVM into all these libs so that linking takes a year. It's insane. All right. So this is in right. So we're assigning it. Okay, hold on though. Oh, this is the sret thing. So is sret, that's just a call thing, right? Let's figure that out. Sret index. That, yeah, this is only a call thing. So can do that. And that means that we don't ever have to worry about this because this does not work for C. Wait, except it does. Wait. Okay, we'll worry about C later. It looks like we can. I guess that changed for 64-bit. Yeah. Okay. The old calling convention didn't work this way. But we don't care about that. Oh my God. If we were supporting 32-bit calling conventions, that would drive me insane. It's already bad enough. All right. So make sure I didn't break anything there. While we look at the LLVM version. So why isn't this doing anything? Did I literally make the compiler infinite loop? What? Wait. Dude, I literally just made the compiler infinite loop. Wait. Did I delete that whole thing? Guys, what is going on? Now I don't even know what I changed. I put that assert on sret index, but that's not. What did I change? Did I not successfully compile? Did I forget to compile the compiler after that frickin' register change? And I thought it worked, but it was really the old compiler. I mean, I don't see any other change. Okay. We're going to try backing this out. Oh my God. Guys, all I wanted to do. This is so confusing. What I started to set out to do tonight was so much more than what we're actually getting done. Holy shit. Okay. It's one of those days. Okay, we're going to do this. Right? And then why don't I just go on TikTok and say ice cream so good all day? You know, why don't I just do that? That would be easier than this. Okay, so what we are concluding is that change actually didn't work for some reason that we don't even know what it is. All right. I would like to get some resolution on this issue on some piece of this issue tonight. Okay. We're going on 5 hours in. So either I can't skip this for some reason for these guys, or, oh, by the way, if we're C-call, we're doing, like, it could be a C-call problem. It could be all kinds of things. Let me just put this back for a second. Okay, yeah, that totally fails. I guess I just did the thing where I forgot to recompile the compiler. All right, so, or maybe I changed, after this worked, I changed it when I was looking and talking about vreg allocate or something, or vreg write. Okay. Well, why is this wrong? See, we're still overwriting it here. So, maybe that's a problem too. I don't know what this does. don't think I need that preg allocate line since it is reading the vreg. No. No, the idea was, you know, because we were, in the case of big values, we were writing back to, we were assigning to this, right? It.local register, which again is a terrible name, but we're assigning to this here. I don't want to do that there because it doesn't make sense, right? I want it to be only going in the function. We make sure this is assigned. And, you know, we already do that, right? Like we pass the argument. Where is it? Right. Like this is where we get the pointer to pass it into the function. And so I'm just trying to write it there, right? Or there. But I am writing it. I'm not really sure. I mean, I feel like the next step is looking at machine code, which I'm not thrilled to do. But I don't know what else I'm going to do, so. I need to just hire a team of 16 people to do this for me. You're going to have to ship a game. Oh yeah, Visual Studio was crashing last time we tried this, so let's see if Visual Studio feels like coming to work today. It's still starting up mega huge and on both displays because Microsoft doesn't understand dual displays. Oh, we can't even go into main. We don't even get to main. Allocator proc, init if needed. Okay, so here, yeah, this is a big value. We're doing an assignment. This would probably later use the optimization we're talking about, but it doesn't now because we haven't even hooked that up. So we are, oh wait, no, this is going to be a pointer size, right? Because we're testing it for, default heap is a pointer to a pointer, I think. Heap acquire, heap allocate. See, I like this a lot less. I thought I was going to be in our simple sample program, and now I'm like in all this crap. Atomic exchange, ASM lock exchange Q value dest. So one of these is obviously wrong. Like that. That is obviously not a memory location that's any good. So heap, when we created the heap, we got back trash, right? It's just, this is much more complicated code than I want to be trying to look at right now. Like, God only knows. Because these are small values, so but like, you know, any of these functions could call another function, could call another function that way down returns a big value, right? I don't really love getting into that. This is already inside a not C call. If I assert mapping is always FFs to narrow the problem down, does it fire? The move 64 indirect seems weird if you're trying to load temp with a pointer. No, I'm trying to store temp. That's the confusing is this goes both ways based on that, right? So temp is the address of the pointer that we pass into the function, I assume. I think that's right. So I'm just trying to store this also in this that we decided to reserve for the thing. But yeah, we could try it. You know what? By definition, the mapping actually should be unmapped. It's a good point because this could never exist. It's never been used. It's defined by the call. So I think that's a good point. Actually, also, we could leave these commented out and see if it crashes only due to this for some reason. Or, yeah. All right. Okay. So that's fine. It runs fine. Yeah, I could put a comment there. Local register is guaranteed to be unmapped because it is defined by this call. That is the whole point. Okay, so we're going to assert that. We're going to do this, and we're going to delete that, and that makes me happier about this at least. So we chuck that in memory. Now I think this is, sred index is equal to -1. Wait, what? I guess we never what? What is sred index? Why are we setting sred index if it's not a C call? The hell? Is sysv C call? C call. C call. C call. Is this uninitialized? What's going on? Oh, because it could be -2 for some reason. All right. That's probably what it is. All right. Let's run that whole thing again. We're being paranoid. Progress has been slow today. But the alternative to this kind of thing is to be afraid of how your backend works and forget how it works, and you try to tweak something and everything crashes, so you give up, and then that's when your code is dying, is when you're afraid of it. So you don't let that happen. I don't know why this is taking so long, but all right. So that is good. That is good. Okay. This part, I sure feel like... Okay, well, we also know that if it's storage for big... Okay, first of all, guys, I know what the fucking problem is, or what a problem is. See this? See this? My brain just turned on. What's wrong with this? Can anyone in chat who has been following along for 5 hours tell me what's wrong with these if statements that I put in? Anyone? If you get it right, I'll say, gang, gang, ice cream so good. Yes. Yes, it is -1. Nobody called me on it when I typed this. All right. So we got that as well. I don't know if that's the only problem, but basically, since this is always -1 right now, because we're never assigning it, then even for small, basically we never copied any small return value. So of course it doesn't fucking work. What? But it's like I went to programming school at Y Combinator or some shit. So that was like 45 minutes. Two people got it. So that's great. Yeah, that was stupid. That was really stupid. But it led to that simplification of realizing that it wasn't ever going to be mapped anyway, which is good. Okay. Well, that's a relief. It's a very hard one, small change. But again, this means now, what is it? What does it mean? It means that here, well, okay, this is SRET index anyway. Yeah. We'll deal with that when the time comes. Yeah, it means that instead of doing all this stuff, we could pass in a pre-existing register or value number, whatever virtual register, and we're not going to clobber it back, which I guess doesn't matter. It's just stupid because here in this version, it already exists because the reason we're passing it in is because it's the address of something on the stack or whatever that we already had. Here, the reason we write it back to the value is because it didn't exist yet. It's like we have, you know, people who were watching 3 hours ago. Remember, we had this like return base, and at the return base, there's some number of value numbers that are reserved for return values. But because we don't want to spam bytecode instructions of like defining those, we let the call define them. That's sort of what's making this a little bit more confusing as well. But in the case where they already exist, you don't want the call to define them. And so that's what we're so the call was overriding it later, which in principle does not change the result as long as the callee doesn't trash its stack. But it's an extra instruction, which is not good. And it's just confusing. Like, why is it writing this thing back? Right? It just shouldn't be doing that. So this is better. Now I have to check LLVM. Why didn't the borrow checker catch it? Small value thing almost seems pessimistic since now we have an extra move on the caller's side. Well, is there an extra move? I mean, the question is just what's the calling convention, right? And I mean, we could define the calling convention to be whatever seems good. In this case, it's just like, you know, the caller has some registers, and of course we need to put the value in those somehow. And you can't, you know, in the big value case, there's pointers to the values because we have that because they're big, right? But in the small value case, we don't want to require that. If the caller had to spill the register anyway, we could write directly to that pointer. Is that a good policy for return? Like, it's weird, right? This is something where probably a very intelligent, data-driven decision could be made, right? In the old days, you would be like, no, don't spill that register because the function you're calling might be really small and might not use all the registers. So you might just be able to keep the value in the register. But in reality, small stuff gets inline now, right? So if you're calling something, it's big. And like, what are the chances that you could keep your thing in a register anyway? Maybe very small, right? Maybe it's not even worth worrying about. And for maximum, like, you could imagine that for maximum simplicity, just all return values are written into memory. That's it, right? If the conclusion were that that's not realistically going to be any slower, I would be in favor of that. Because it definitely simplifies things. worth considering. None of this matters for the LLVM backend because the LLVM backend still uses different calling convention. So I need to go look at that. Okay, let's make sure Sokoban compiles and take this very hard-earned W, if indeed it is a W. Wait, did we actually get some Weissman score from this somehow? We got like 13 instructions of Weissman gain. Somehow out of that. Yeah, I will take it. Today's been a rough day, so we're going to take the credit for that. Massive wins, guys. Okay, this is running. It's just taken a long time. This game's going to be so awesome. Okay. Yeah. Yeah, for the small value thing, I wonder if I were fresh in a morning sometime, I could just really quick program a thing to say how often when you call a function, I mean, you really only care for release build, right? How often when you call a function like that, does the thing actually stay in a register all the way till the return? Well, okay, well, it's complicated, right? Because the function you're calling doesn't know, obviously. So it would spill that register. I mean, maybe what that really means, I haven't thought about calling conventions much in a long time. But like, if the callee can assume that it could use basically any register, then functions wouldn't have as much like spill things, preambles, and postambles, right? Because that's kind of silly, right? Like if every, so the default assumption in something like C yeah, again, the default assumption for something like C was yeah, you want a lot of callee save registers. I don't think, yeah, I would rather just not have that. I would rather just say there's no such thing as callee save. I don't see the point. Maybe in reality that doesn't totally work, but I do think once you're inlining, it helps when the function is small enough. Yeah, but I mean, again, the theory was that small things get inlined by an optimizer anyway, right? Which in the x64 backend, we don't do that, but like not, you know, we only do it if you explicitly say, and if the inliners turn on, which by the way, I think last time I tried to turn on the inliner by default, Sokoban was still crashing, so we still can't do it. I thought we could try that now actually. Anyway, yeah, but like planning for that, just because we don't do an optimization pass that inlines in the x64 backend now, that doesn't mean we should think about that as being the way code really is, right? So I think if you assume that everything small got inlined, yeah, like how often is that actually going to happen? Right? At which point, if we just say, I'm a big believer in simplifying things. If we just say there's no such thing as callee save, that's probably a win. I feel like. I don't know, but I feel like it is. Just things are so complicated already. Let's see. Let's did I think I committed this, right? Yeah. Although I don't like this file is modified. So I don't know what I checked in. Okay, white space change. Great. Um, calling convention code is by far the most complicated thing. I know it's crazy, and you wouldn't think like when you're writing down a calling convention, you just think like, oh, what's the big deal? Just do this in this case and whatever, and it just gets bananas. It just gets bananas. And I guess there's two different things. There's like, is there callee save? And are there arguments passed in registers? Which like, I mean, maybe there are arguments passed in registers, but even the problem with that is like if you just do regular code generation, they're not going to be in the registers that you wanted them to be in for the calling convention naturally. But I guess register to register moves are basically free. So that's not that big of a deal. I don't know. yeah, the idea of just making the calling convention just be return values are always written to memory. I do kind of like that. But we're not doing that tonight. Okay. Inliner. So I think let's do, because it'll take a little bit to make a release build. So we're just going to try. So first we're going to make a release build without the inliner and verify it runs. Actually, no, because well, if it runs with the inliner, we don't need to do anything. So just make sure that we're getting the right build configuration. Do we set the back end? Yeah, I don't know. Okay, those are different targets. All right. Let's see what happens here. It's going to take a while. It's going to take a while. Gonna take a while. It's gonna take a while. It's gonna take a while. Don't you have a calling convention definition? Why are you guessing about what ends up where? You kind of have to have a calling convention definition because, like, otherwise you can't compile anything, right? But it's like I made it up a long time ago, and then some other people modified it, right? And I don't remember exactly what I mean. I remember, like, for some reason, arguments are easier for me to remember than the return values somehow. And the LLVM backend doesn't even use the calling convention that we use in the x64 backend. You know, there's reasons. But also part of the reason is I never took the calling convention very seriously because, you know, I generally had some ideas about how it should go, but like you don't really know what's good until you run it on a real program, which I didn't have back in the early days of the compiler, but I needed to make it do something, right? So I just did some stuff, and then I was like, you know, someday later we'll come back and look at this and see how it is. I mean, it sure seems like it's working. Maybe it was that some tests were failing. If we make it the default. I mean, this is working, so. That's cool. Maybe I didn't have all the updates for some reason and thought I did because once again I didn't recompile the compiler or something. Let's try this. Enable bytecode inliner. So that's set to false. We're going to say true there, and we have to go in the compiler settings, enable by true. Okay. This is what I think didn't work. We'll see. So now it should be enabled even for debug build. I don't know, it's kind of working. Maybe it doesn't work on the tests. Let's try it on the tests. Maybe I hallucinated that. I am in mountain time. That's right. I mean, it sure looks like it's working. Okay, well, that's a W. Okay, I don't... We never shipped a 7.3b, so this is going to be 7.4. Bytecode inlining is now enabled by default. For example, modules, compiler, build options, enable bytecode inliner defaults to true. This is not an optimization pass. It only means things you explicitly mark inline are inlined by the compiler. Middle end. Yep. Well, it's about time we turn that on by default. Please let us know if you experience weird code misbehavior due to this. If you do, you can set enable bytecode inliner false. Actually, let me check default metaprogram. No. We might want to put an option in here to turn that off, but better to have faith. All right. We're approaching bedtime, but I just want to look in the LLVM. Poke return value. If it's a big argument, we do a mem copy. Right? The register's in the same place. It has to be, well, it doesn't have to be actually, but it is. We do a mem copy. Otherwise, we don't. That mem copy should be the same regardless of whether the pointer was created during the call or pre-existed. Like this should still be necessary actually, but I mean, this never gets invoked yet. So again, we have a linear allocation. We do this slow crap to find it. We add it to the argument list. We create a store into the local register. Yeah. I mean, this looks fine. We do the call. And then we don't really do anything special on the return, I think. Yeah. So this looks more like now what the x64 one is. Score probably went up to the inliner. Oh, dang it, dude. You're very likely correct. But since we're not really doing, it probably went way up, right? But that doesn't count. Next time we optimize, we'll go for the new Weissman 552360. No, it actually went down. Maybe the inliner doesn't count. These. Number of hold on. Where does, okay, great. Total bytecode instructions. Where does that come from? Current serial. Yeah, that's probably not being incremented. Yeah, it only gets, so what happens is the reason it went down is probably because we got rid of some call instructions and replaced them by things that aren't counting, although I would have expected it to go down by way more. Yeah, this just wait, no, because we call instruction. For every instruction. I'm confused. Maybe it's not working. Maybe the cake is a lie. Well, we got here. For like some function call. Atomic compare and swap. That sure sounds like something we would inline. Atomic compare. Wait. Why is it called atomic compare and swap? Whose is that? Oh, it's in default allocator. Sure is marked inline. So I don't know. I don't understand the numbers that are happening. It's a very confusing life that I am living currently. Did we get, we actually did get more gains, but I don't, it is beyond explanation as far as I'm concerned. Like, I kind of don't trust the numbers at this point. Although, I mean, again, calling functions isn't free, right? It's not just the call instruction, but there's, you know, instructions to set up the arguments. It might just be that for some reason it was very close to break even for the things we have marked inline. I don't think that sounds super plausible, but it might. Like here, you know, this function is literally just another call, right? With a plus. And then that call is just an ASM, right? I don't know. We'll see. I'm going to enable it. Okay. Enable bytecode. Well, I didn't expect that either today. All right. Well, we went on a big journey. So that was fine. And made some relatively small changes. Although we put in a bunch of that code for the thing I'm trying to do. And hopefully we should just be able to turn that on next stream. I feel like there's still going to be bugs, but now that I've reviewed how everything works and I'm not confused anymore. Oh, there is still the thing. There's the question about actually, you know, earlier in the stream, I was like, do I want to change how the compile time execution version works? I think that's not really necessary. Because that return register base stuff that it's using is actually the same thing that the backends are doing. So it's not different and more complicated in any way. It's just fine. Right? And then I just need to audit that to make sure that it's doing approximately the same thing. Which it mostly is. there's just this question about, again, it's probably writing back to the thing on return, and we don't want it to do that. So we want to do a similar change to what we did to x64. But I have officially reached the threshold where I'm tired enough that I should not do this tonight. So I'm going to go to bed. Thanks everyone for being here for a 5-hour and 45-minute stream where slow progress was made. And always remember, if you want to succeed in the games industry, compare the variable against -1. All right. Thanks, everyone. See you later. Don't forget the -1.